Welcome back as we move into the assembling section. Assembly normally begins with securing the drive end bracket into the bench vise. The armature, together with the shifter fork, and most usually with the solenoid plunger, is next carefully positioned into the drive end bracket. Note whether any alignment marks correspond at this time. At this stage, on most starters, the shifter fork's fulcrum pin would be next installed. The pin and fork need to be aligned to ensure that the pin enters the fork, after which it must be threaded into the casing. Next, the field casing can be slipped over the armature, ensuring that the alignment markings match up. Whilst support on the body or frame is maintained, the commutator end housing can next be fitted. Note that the two field brushes are kept out of the frame at this time. The commutator end housing must be carefully aligned. The earth brushes are pulled out of the frame to prevent them binding against the commutator. Now the housing is pushed into position. A check is made to ensure that the brush leads are not binding. We are now ready to secure the unit with the through bolts. Both bolts are positioned through the casing and then secured evenly, thus avoiding any distortion. Turning the armature via the pinion gear will assess whether the armature rotates freely. A sticking or tight armature can be the result of not evenly tightening the through bolts. The solenoid can next be fitted. On our model, the shifter fork damper is first positioned as shown. Now the solenoid unit can be slipped into position and secured firmly. To reposition the brushes, the hooked tool is used. Carefully lift the spring and slip the brush into its holder. When returning the spring, it is important to keep it central on the brush. At this stage, it is usual that brush spring tension be checked. However, the exact procedure will be covered in the following program. The brush cover can now be reinstalled before we move on to an important adjustment procedure. On this starter unit, the pinion gear must have a specified clearance between the edge of the gear and the pinion stop collar when the solenoid is pulled in. The pinion stop clearance is achieved by rotating the fulcrum pin. The eccentric offset on the pin results in the shifting of the operating lever position and thus the position of the Bendix unit. A gap of 0.3 mm should be achieved to ensure proper pinion engagement into the flywheel's ring gear. Too large a gap will cause uneven tooth wear, whilst no gap will result in damage to the pinion stop. The procedure for setting the gap involves firstly connecting the solenoid to a standard 12-volt automotive battery using normal battery jumper cables. We'll look at the connection in diagram form. First, we connect an earth between the battery negative and the starter frame. Next, we connect between the start connector on the solenoid and battery positive. Now, using a heavy-duty cable, a brief connection is made between the solenoid motor terminal and the starter frame. This will activate the pull-in winding. As soon as the pinion has moved out, we disconnect the jumper and the hold-in winding will keep the pinion engaged until such time as we break the circuit. Whilst the pinion is held in the engaged position, the pinion stop gap is checked using the 0.3 mm feeler. Adjustment is made and the lock nut tightened. As soon as the adjustment has been made, the battery has to be disconnected. The solenoid windings will heat up during the test, so we do it as quickly as possible. Finally, the motor solenoid link strap is reattached to complete the reassembling procedure. After a rebuild, a starter motor should be bench tested. This procedure is covered in program AEM2 of this series. This concludes the starter motor dismantling and assembling program. Join us again in other Tech AV programs on automotive electrical maintenance.